Hello, I'm going to talk to you today about how forces are in fact something we call vectors and how we deal with them as vectors. We have drawn here a free body diagram with four forces shown. Notice that unlike the other times we've had free body diagrams, a couple of the forces are horizontal and vertical, and then there's one force that happens to be at an angle. Because forces have a magnitude, such as 5 newtons here, as well as a direction, you can see that this one is at some angle above horizontal. Because they have magnitude and direction, they are an example of a vector. So, vectors have magnitude and direction. If by chance we had something which did not have direction, it's just a magnitude, that's called a scalar. Because they are vectors, we are going to go ahead and learn special rules about how to add them, how to describe them, and we're going to start that right now. So, those of what I want to show you are the following. First of all, how to describe a vector, and then after that, we're going to be describing how to add vectors. That will be in another video. So let's start with how to describe a vector. Here you can see a drawn vector. The vector has a magnitude and a direction. The first way to designate to describe a vector is to go ahead and to describe both its horizontal and vertical parts, otherwise known as components. If we go ahead and take this vector and we describe how to go from the tail of the vector, and all vectors have tails, so this is my tail, and this is the head of the vector. If we describe how to go from the tail to the head, one way to do that is to go ahead and say, well, if we start at the tail and we go ahead and draw an arrow going over to the right 4 units, and then up 3 units, that ends up taking us from the tail to the head in 2 different steps, where one is horizontal and one is vertical. As I draw that, this one has a 4 Newton length, and this one here has a 3 Newton length. And we will come back and we will describe this as being 4 units to the right and 3 units up, or maybe in something which looks like coordinates, as if you were doing this on a graph, where it would be 4 over and 3 up. When we do this as coordinates, you can see that the first one is typically the horizontal, and the second one is the vertical. It is possible to have a third one if you have 3 dimensions, but we won't go there. So that's the first way of describing a vector. This is known as giving its components. The second way, notice we have the same vector here, is to go ahead and describe its angle or direction. So maybe you could go ahead and say, oh, well, this is at 36.9 degrees up from horizontal. That's the direction. And in addition to giving the direction, we also need to give the magnitude. And in this case, because I see that it looks as though we can go ahead and draw a triangle here, where the sides are 4 and 3, and since we can do the Pythagorean theorem to say 4 squared plus 3 squared equals, let's call this A squared, eventually we would see that A equals 5. So the magnitude of this vector then is 5 newtons. So this is known as giving the magnitude and direction. Okay. Let's see. So, next thing is how to resolve a vector into components. We use this word resolve for something very specific here. And that is, for us to take a single vector that has some given magnitude, so this one has a magnitude of 5 newtons, and to go ahead and describe it not as 5 newtons at some particular angle, but rather to go ahead and describe it in terms of its horizontal and vertical components. This is going to look very much like what we had done up above. So, in order to do this, I'm going to go ahead and grab a rectangle and draw a rectangle. Let's see if I can get this here. Draw a rectangle. I'm still trying to get it. So it begins at the tail and ends at the head, where the sides are horizontal and vertical. If I go ahead and do that, and then come in and describe a vector here that goes horizontally and then vertically, that gives us a vector of 4 newtons and 3 newtons. So 4 newtons to the right and then 3 newtons up is equivalent to have a vector which is 5 newtons at the original angle. I would summarize that by saying, if we have a vector that looks like 5 newtons upward drawn here, that's equivalent to having two different vectors, one which is 3 newtons up, and another which is 4 newtons over. Those two are the same thing, just written in two different ways. Thank you very much. The next video will be about how to add vectors.